All. Today we'll discuss VoLTE in IMS. In the year 2015 is definitely a year of VoLTE. VoLTE is everywhere and operators are rolling out a crazy way. There are plenty of articles describing how the LTE or LTE advanced do work. We'll put the LTE packet core part inside and take a look on the IMS related VoLTE architecture and its call flows. Voice over LTE service specified in GSMA IR.92. If you think it seriously with VoLTE, don't waste your time on any blog or read the VoLTE service description and implementation guide. On the other hand, real beginner can try our VoLTE illustrated beginner guide. So this is the overall architecture. This is our UE, belongs to 2G or 3G network. Is connected to the MGCF media gateway control function. Also, it's connected to border gateway control function. Another site, another UE is a VoLTE enabled, like 4G enabled UE connected to EPC. Then is directly connected to primary CSCSCF. Then is connected to SCSCF, and this is the our media resource function and telephonic application server TAS. This is our HSS home subscribers and it's our DNS domain name servers. Let's see. So we'll discuss about the PCSCF, proxy call session control function. An entry point of for IMS signaling. It is directly connected to the VoLTE device over SIP protocol, session initiation protocol. PCSCF maintain the security association between itself and UE. Then ASBC, Access Session Border Controller. It's a provide connectivity for two or more IP network, including IP version 4 and IP version 6 network interworking. It's also help NAT transversal or ETC. Implement security features like DDoS attack prevention and hiding topology like network topology, encryption and CAC. It's also communicated with access network like LTE and is responsible for quality of service. It also handles media services, provide transcoding if needed. What is the meaning of transcoding? When two different device can communicate with different codecs. It's work as transcoding. For the end-to-end signaling, voice call setup, we use SIP protocol, session initiation protocol for voice and video. The multimedia then goes out of band using RTP protocol, real-time protocol. The heart of IMS is IMS core. The heart of IMS is IMS core. It consists of often co-located I and S CSCF. It's like a session border SBC. It's like a SBC, session border controller, which cares about authentication, session routing and management. Let's see ICSCF. Integrating call session control function. So ICSCF provides a location services. That means that for each subscriber or public services. ICSCF is able to locate the right SCSCF. It means ICSCF helps to identify the right SCSCF for particular UE. ICSF also represents IMS network to peers. Example for peer network, the ICSF is the first point of contact. If any operators users can call to another operator's users, they will connect through ICSF. Then SCSF, serving call session control function. The SCSF is responsible for basic IMS services. It is a SIP server providing session setup, session tear down, session control, and routing functions. SCSF acts as a SIP registrar server. It stores the binding between public user identity, SIP URI or TEL URI, and its actual point of presence, contact IP address, and maintains user registration status. During VoLTE registration procedure, SCSCF perform user authentication. So it perform user is authentic or not. Work lies as a gateway. SCSF also invoke application server like TAS, IPSMGW based on rules IFC filter criteria received from the HSS. The IMS core, however, doesn't know anything about voice or SMS services. The IMS core, however, doesn't know anything about voice or SMS. That is the task for application servers. The application server for voice and video telephony is called TAS. The application server for voice and video telephony is called TAS. Telephony application server or MMTELS application server like multimedia telephony application server. So SCS is a main function to provide first contact to UE, work like as a gateway. It's hiding our network topology. It's provide authentication to the user in the registration process. Then we'll discuss about the telephony application server TAS. The application server responsible for all the services as address normalization, call diverting, call forwarding, and call bearing and etc. In a nutshell, TAS is what makes the VoLTE enhancement on top of the pure VoIP. VoLTE specification also defines SMS interworking. To support SMS over SIP, we have a dedicated application server called IPSMGW, which work for SMS related works. In more detail, it is described in IPSMGW part. Transport level interworking post. IMS core and application server doesn't have any persistent storage. All the information about subscriber and their services is stored in HSS, home subscriber server. The communication between HSS and ICSCF and SCSCF or TAS make use of diameter protocol. So diameter protocol is a message based protocol where we'll send the request and response come from the other end. So other IMS related nodes are MRF, media resource function, which provide media related things, can be used as a media mixer or a media server for playing tones of or announcement. MGCF, media gateway control function. MGCF is used for breakout to and from CS network. Usually the MGCF and MGW media gateway is a part of enhanced MSC. When we are making to call, a call or break out the call from a legacy network, so MGCF will work on that condition. BGCF, the breakout gateway control function. BGCF might be used in case when SCSCF is not able to find the routing based on ENM or DNS. For example, PST numbers. Usually it's a part of IMS core along with SCSCF and ICSCF. The IMS definition is very broad and flexible. GSMA VoLTE standard restricts it and defines what services are mandatory and how we should implement them. It defines how to implement emergency services, SRBCC, roaming, SMS interworking, etc. It's our post. We will go through the basic LT to LT call flow. You can see the call flow but UE belongs to 2G or 3G. It's going forward to initiate a call to MGCF, and MGCF is directly connected to integrating CSCF to find out the SCSCF, in which SCS the user will be available. And like here, non-trusted network, Wi-Fi, Web RTC, WLAN, EPD is connecting for Wi-Fi, act as a gateway to the PGW, and this is our LTE where is directly connected to SGW, PGW and its PCSCF towards here. Then is connected to SCSCF. Then IPSMGW for SMS related thing. This is HSS and this is DNS. So this is overall, this is the architecture we can learn here to call flow. How our node will be performed based on our UE either in 2G, 3G UE or LTE related UE. So here we'll discuss VoLTE call flow. We said that SCSC is heart of IMS, that is MMTEL is the brand. There are always at least two telephony application server and two SCSCF involved per path from originator to receipt. One which applies originating and one which applies terminating services. Here the UAC user agent client and US user agent server. Let's operator A, operator B, and SIP invite sending to the PCSCF. We'll show in a tool the real time how it's look like invite message. So this is the UE. We are sending the invite request. In invite, lots of things. In invite, lots of headers is available, like via max forward prompt to call ID, C sequence, contact, accept, allow, proxy required, piece, proxy required. So multiple things. When you will learn more, you will connect with us. The invite sent and a request sent to the PCSCF, and you will get the address of during the PDN connectivity request. You will get the PCSCF IP address. So when sending the invite, so directly go to the PCSCF. Then PCSCF send the request to related SCSCF. Then SCSCF is sending to the another operator beside SCSCF directly, and ICSCF. ICSCF will identify relevant SCSCF, then SCSCF forward to its PSCSCF, then the call will be matured. Then a party UAC and a US will communicate on that time. RTP we will set up real time protocol, then we'll discuss later. What particular service will be applied driven by the configuration of TAS, MMTEL by subscriber and non-subscriber data which is stored in HSS. Before a subscriber can place or receive any call, it has to register himself in the IMS network. We went through the registration in several posts, registration, how to read TCP dump, registration and everything. Once the user is successfully registered, the SCSCF is able to route the incoming calls to the user. The SCSCF also knows which task did the third party registration and maintain a binding between the input public user identity and the task. This information is a part of user context. When a subscriber John wants to initiate a call, he sends a SIP invite message to the receipt Rory. It's a John, it's a Rory. The basic flow looks like this, so we can understand. So VoLTE to VoLTE call. John is sending SIP invite. It's sending invite request to the IMS. IMS forward to the request invite request to the Rory. And here SDP is optional. And in SIP invite request, SDP is already available. SDP is a session description protocol. It's related to media capability, related to codecs, which codec John is offering. And behalf of this, Rory is sending in 183 message. Whatever the Rory handset having the codecs, they will offer, then mitigate and match the relevant codec which are common for both sides. Then John send SIP prac. Prac is a provisional response, not a final response. And behalf of prac, Rory will send 200 OK behalf of prac. Then John is sending SIP update along with our SDP, and based on update, Rory sends 200 OK and match the SDP criteria and can start the ringing. And finally 180 ringing, John is receiving, and also Rory sends 200 OK. The John is acknowledge the call, and both sides we can communicate the setup RTP real time protocol. So in this process, SDP negotiation is happened, and after SDP negotiation, they will match as per available codecs and fix The RTP, after the acknowledgement message, they are talking each other. Then Rory is going to buy, maybe the communication done, and the behalf of buy, the John is sending 200. Okay. So this is the basic call flow. Inside IMS is there. So if SBC is there, so SBC will, whatever the A party will sending invite request, so SBC will forward to the B party, like the forwarding, like routing. So let's see further. Multi-subscriber use SIP protocol in order to negotiate the parameter of media, multimedia RTP session. The SIP signaling also allow the IMS network to secure sufficient resource for the requested quality of service. In the IMS, the SIP invite message is firstly sent to PCSCF, which was assigned to the user during the registration. The PCSCF has a binding with SCSCF, which is responsible for the originator. The SCSCF routes the SIP invite to the originator task, which applies originating services, outgoing call bearing, triggering of playing announcements, conferencing, etc. Can modify the receipt address based on translation rules, enum response, camel triggering. Camel is also protocol. Remember that tasks act as a back-to-back user agent and can change any SIP header including the call ID. From originator task, the SIP invite sends back to the SCSCF of the originator. The SCSCF find a routing to the network of the receipt help of DNS or ENM query. In our case, receipt is registered in IMS SCSCF. Forward the message to ICSCF in the terminating network. ICSCF will locate the SCSCF which handles the context for the receipt. SCSCF triggers T-task for terminating services, incoming, call bearing and call forwarding. Finally, the T-task forward the SIM invite to the SCSCF of the receipt. The SCSCF knows which PSCSCF maintains dialogue with the receipt. When the receipt receives the SIM invite, he will respond and the response backtrack all the way to the originator. Here user A, here user B, originator SBC with PCSCF, originator SCSCF, TAS, ICSCF, SCSCF, TTAS, terminating site TAS, terminating site SCSCF or PCSCF. So this is the complete call flow. For more detail, you can connect. We'll discuss along with each message. So please note, so far we have been talking about logical flow. Physically, the originator trace and transmitter trace can be just one server. Originator and receipt are both registered on the same CSCF using the same SBC, like this one. The server is common. For example, we are discussing originator and transmitter and the same task and same SCSCF and same ICSCF is available for this call. So SIP routing of VoLTE call in IMS is more detailed discussed in SIP. If you looking for detailed SIP and IMS, where we'll discuss each and everything into the detail along with simulator where we can generate a traffic. Earlier I saw the tool SIP session routing. In order to establish the media path, body of the SIP invite and other signaling messages carries session description SDP data. This is the version of SIP. This is the originator. This is sender. It's a voltage session, a core port, time, media attribute, audio. It's based on codecs 1164, AMR 1118, AMR 8000, 1111 telephone event, 1110 telephone event, 110 84 PCMA, 04 PCMA. So it's related to codecs. By SDP, the originator and receipt exchange IP address and its port for the media stream RTP. Set of supported codecs AMR, wideband, AMR, DTMF, telephone event. There are many more parameters. For now, it's important that once originator and receipt knows the IP port and codecs to be used, they can start a communication over the RTP protocol, real-time protocol. So first SIP, then SDP, then RTP. We'll set up. We'll discuss into the detail every protocol along with its header. Like in this call flow, UAC user agent client and user agent server, they are negotiating the SDP. It's called early media. They are offering along with an SIP invite message. Let's match the common things and both the media line having the common things like 118, 118. So they will set up RTP through 118 codec. So it's called SDP exchange based on available media codecs. The whatever the common codecs they will use to set up a call, and they will set up RTP real time protocol. Later, when on the call parties wants to close the RTP stream, hang up, the client sends a SIP by message. After the 200 OK response, the session is finished. Maybe you can ask why this is signaling so complex. That is because of the IMS is very journal. In case of roaming, this simple scenario can go across our different IMS network like operator B, operator C, operator A, operator D. So it's a very simple things. When you will learn into the detail, it's a very easy full learning. Many telecom engineers are moving into IMS. Lots of scope. Every operator are using IMS across the world. The big player of IMS, Nokia, Ericsson, Movenier, is a big manufacturer. In operator side, all operators are using IMS. Before that, SIP is using VoIP. 300 plus companies working the wipe across the globe. So for more detail, you can connect with our team. You can in this number you can connect. You can connect with Deepak. You can visit our website. Although currently nearly no operators support IMS based roaming, and mostly they are not connected or any other IMS network at all. Still, the network architecture can be quite complicated. Operator have multiple sites and they can be several different type of sites: access site, core site, maintenance site, failover site, and RCS sites. So, for more detail, you can connect with our team on below number. Thanks for watching this video. You can follow our YouTube channel for more update. This type of video you will get on daily basis. So happy learning with ATS.